We have a nice short lesson. This is it today. So yesterday we were talking about the side, and side angle, side congruence, which turned out to be pretty easy. Side angle, side, you had to make sure that the angle was between the two sides, so that was really important. We want to be able to also prove triangles are congruent in the coordinate plane. So, and again, I've talked about coordinate geometry a lot, or before, and so this is a lot of geometry when we put things in a coordinate plane, the XY coordinate plane. And we want to see if all three pairs of sides happen to be the same length, okay? Well, guess what? We're going to use the distance formula. All right. For all the money in the world, do you remember the distance formula? Big giant square root. It doesn't matter. It's x2 minus y1 or x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We're finding the distance between the x's, so we're subtracting. That always is going to give us the distance between two things, and squaring them. All right, and added to the difference in the y's squared. Okay, so we have it nicely set up for you here. Given the coordinates, determine whether triangle PQR and triangle XYZ are congruent. And so to figure that out, if I have, like here, I'm just going to just draw a picture because I like to just have a picture, PQR, and maybe we have triangle XYZ over here, okay? And so what we're doing is we have to just look at the three sets of sides. So here, I'm going to try and find the length of side PQ. Here's our first side, all right? And so I want to use P and Q and my distance formula. So the length of PQ is going to be subtracting my x's and squaring, and subtracting my y's and squaring, all under a giant square root. So let's see. My x values, what should I do? -3 minus 5. Beautiful. And then my y values? 7 plus 4. Minus a -4 or 7 plus 4. Beautiful. Okay. So yes, again, minus a negative does turn to plus. All right, and so we get under the big giant square root. What is -3 minus 5? -8. It is -8. And then if I have to square that, that's -8 times -8, which is positive 64. And 7 plus 4 is 11, and 11 squared is 121. And if I add those numbers together, 64 and 121 is 185. 185, all under the radical, the square root of 185. So now what I've done, well, the square root of 185, let's see, 144 is 12, the square root of 144 is 12, the square root of 169 is 13, so this is bigger than 13, all right, something centimeters, or whatever the units are here. All right, well, let's go, keep going. So Q and R, we just want to make sure I'm using the right ordered pairs here. So now, using points Q and R, again, giant square root. Set it up. You've got your thing squared plus your thing squared. And we need to subtract our x's. So we're going to have 0 plus 3. 0 minus a -3, which turns to plus 3. And then subtracting the y's, 2 minus 7. 3 squared is 0. Whoa, 9. It's too early. All right. 2 minus 7 is -5. And what is -5 quantity squared? Positive 25. Yes. So -5 times -5 is going to give us a positive 25, and then that is going to be 34 under a radical, so radical 34. So between Q and R, we get a length of radical 34. Estimate that for me. What about is radical 34? What about is radical 34? How long?
A little shorter than 6.
A little shorter than 6. Very good. How do you know that?
Yeah.
6. Yeah. So the square root of 36. Square root of 36 is 6. This is a little less than that. Because the square root of 34. 34 is a little less than 36. You with me? Yeah? Square root of 36? 6. All right. And then P and R. So now we're using point P and point R. So again, here the really big thing is just making sure that we're pulling from the proper ordered pairs. All right, giant square root. Square some stuff, added to square some stuff. All right, so my x is 0 minus 5. And then 2 minus a negative 4, which becomes 2 plus 4. All right, and so 0 minus 5 is negative 5. And negative 5 times negative 5? Positive 25. 2 plus 4 is 6. 6 squared? 36. And so let's see, we get the square root of 61. All right. So our last side here is radical 61. Hey, what kind of triangle is this when all 3 sides are? Oh, it is scalene. It is scalene. Very good. All right, but we want to compare it to this other triangle. So using x and y, again, big radical. All right, we got 9 minus a negative 2, which becomes 9 plus 2. And we have 7 minus a negative 1, which becomes 7 plus 1. All right, we have 11 squared, which is 121. 11 times 11? Not 11 times 2? Right? Yeah, woof, a good thing is Friday. And then 8 squared is 64. So, hey, lo and behold, we get 185 under the radical. So, xy is radical 185, and that happens to match the one right next door. That's kind of handy. So, they have one pair of congruent sides. All right, let's check y and z. All right. So y and z now.
3 minus 9.
And then
2 minus 7.
2 minus 7 quantity squared. All right. 3 minus 9 is negative 6. And negative 6 squared? Positive 36. Here we have 2 minus 7 is negative 5. Gentlemen, side conversations can wait, please. We're almost done. Negative 5 quantity squared is 25. And 36 plus 25 is 61. Do we have a match somewhere?
Yeah.
All right, so YZ is radical 61. So that matches with this one.
Can we say that they're...
Well, right now, they have 2 pair of congruent sides. The third doesn't necessarily have to be congruent. We have to verify. We've definitely got 2 pair of congruent sides. So now we have to check X and Z. So using the last pair here.
3 plus 2.
3 minus a negative 2 becomes 3 plus 2. Good.
And 2 plus 1.
2 plus 1. Excellent. So we get 5 squared is 25, and 3 squared is 9, and 25 and 9 is 34. So radical 34, and once again,
wow.
Wow, amazing. All right, so there's another pair of congruent sides. So, are the triangles congruent? Yes. Explain your reasoning and write a congruency statement. So, since PQ, segment PQ is congruent to segment XY, And QR, segment QR, is congruent to segment XZ. And the last one, segment PR, is congruent to segment YZ. So we have 1, 2, 3 pair of congruent sides. Then our triangles. What are our triangles? Let's see. So if I do it this way, P and then Q and then R. So I'm doing the sort of radical 185 side first. Are you seeing that? Oh, 185. So P, Q, R. So I'm going P, Q, R, radical 185 to radical 34. So triangle. P, Q, R is congruent to. Now I have to match it on the same way over here. So let's see. I did 185, radical 185 and radical 34. So I want to do the same thing here, referencing the same sides in the same order. So radical 185 and radical 34, I got to do triangle. Yes, YXZ. So from the 185 side over to the 34 side. So 185 to 34, YXZ. So that congruency statement is very, very important. And why do we know that they're congruent? What theorem?
Distance formula.
Side, side, side. Congruency, yes. Okay?
Yeah. I think we don't need to do it right now.
Yeah, I don't want to do the next one. I'm not.
Okay.
No.
Hold on a minute, new record.